Hello. How is the tutorial? How many of you attended Tuesday tutorial? Very good. Are we in sync? Not in terms of what is being covered. Are we in sync in terms of how you are learning? Are we in sync? Okay. Matching? Oh, by the way, I have not told you, my room is D220. You're free to come over anytime. D as in donkey. D 220. So since you already went into PDV, everybody open your book. Today we'll do some diagrams, sort of like what kind of problems you will get, how not to get scared of writing diagrams, get the trend right. If you get the trend right, I think you're good. That means that you understand. That is sufficient, yeah? Everybody open your books, let's do some PDVs. Basically work. No, don't want textbooks. Your notebook is good. Hey, so how do we put some statements that doesn't stress you out? So if I block something, what will happen? What will happen to volume? If I block, what will happen to volume? You just say it won't change. Okay? What will happen to pressure? It will build up. If you block something, it will build up. Something will build up. That's what blocking means. What will build up? Pressure. If pressure builds up, if all of you get stuck in an elevator, what happens? Pressure builds up and then what else builds up? Temperature will build up. A lot of friction there. Yes. So can you write in your own words? Very simple. Two concepts. If you block, volume will not change. Pressure definitely will increase. Temperature definitely will increase. No doubt about it. What is the middle ground for it? Don't do any blocking. Leave it to open. What will happen? No, go with the same sequence. What will happen to volume? It might increase. It might phase transition, material might phase transition and volume will increase. What will happen to pressure? Nothing. It will just equilibrate to whatever open place that you have left. What will happen to temperature? Even if you are heating it, it won't build up because you have left it to open. It will keep expanding. Yes? Until after a certain time, after the phase transition happens, it will start to heat up. Temperature might increase depending on your heating or left the temperature as isothermal. What is the reverse of what I told the first one? If I don't block, instead if I release, if I reduce the burden, what will happen to volume? Volume will increase. What will happen to pressure? I am the one who is releasing it. So the pressure will decrease. What will happen to temperature? Decrease. Decrease. So this is the opposite of build-up. There's only two things, block and release. Block is the build-up, release is everything is out in the open. The third thing is I can decrease the stress or the burden. So again, one more time, I hope you have written it correctly. If I block, how do you write it? Volume. I'll just put a two-way like this. That means it's constant, correct? Pressure. Yes? Is that right? Open. Depending on I'm heating or cooling. You should know that. If I'm heating, I'm going to expand. If I'm cooling, I'm going to contract. You can write that down by yourself. Again, temperature depends whether I'm heating, or it can be isothermal, or it can be heating, or it can be cooling. Most important is pressure will remain constant. Now if I reduce the load, I already told you, reduce the load. Sorry, I wrote it wrong arrow, up arrow. Volume will increase. Pressure will decrease. Temperature will decrease. You cannot go wrong with this. Get your trends correct and boldly draw the diagrams. But for this, you have to learn to read the problem correctly. Yeah. Don't drift when you're reading those English sentences. Okay. Many of you misunderstand the question at times. That is all there is. You should not make mistakes with your PV illustrations and TV illustrations. Get that right. Numbers are secondary. So now shall we draw some diagrams, some examples? Before that, I like the fact that you guys gave very good examples of polytropic processes. So you did a derivation for PDV, depending on whether P1, oh, by the way, what is the tracking here in the numericals? You have to track your P1, V1, T1. You should track your P2, V2, T2. Learn to do that tracking before you start answering the question. That is why draw this trend, write this trend somewhere. Track your P1, V1, T1, P2, V2, T2. Then read the question well, understand, and first draw the PV diagram and the TV diagram. You are, I think, 80% done if you do that. There's nothing else after that, just reading those tables. So you gave me good polytropic examples. You want to derive for polytropic? How does the work equation look like? Try it. So you told me it's a multiple what? Polytropic is what? Multiple expansion, contraction. You can change pressure, you can change temperature. What was the example that he gave? He said, how about blowing a balloon? How about inflating a tire? Yeah. All that will work. P is changing, V is changing, T is changing. You can put a spring-loaded piston, you can heat it, V will change. It will push against the piston, P will change. T might change. All these are polytropic processes. Freeze drying is a polytropic process. So your general equation for polytropic is, because it's a summation of multiple PV works. So when you do summation, usually you'll put one exponent. It's just a very phenomenological equation. There is no science behind it. So how do you look at PV to the exponent of n? It's like summation of P1 V1 or Pi Vi from I to 1 to whatever, how many ever PVs are there. Got it? Like this. Just a phenomenological equation. So why does the exponent sit on the V? Because the work is predominantly dependent on V. The major part of the work is dependent on V. So how do you do? Now can you derive quickly? Don't take too much time. So what is the deal here? Once you write PDV, you should ask for, immediately write the next step. You should ask for what is the relationship between P and V. and then plug it into the integral. That's it. Plug it into the integral, what happens? So as you know, you can use P1, V1, P2, V2, state 1, state 2, just like your ideal gas thing, what you did. So what do I get? So constant, this is equal to constant, you can just put constant dV then for constant what can you put? Whatever you want you can put, P2 V2 to the power of n. So what's the integral here? V minus n plus 1 minus n plus 1, yes? Don't forget the limits from state 1 to state 2. State 1 to state 2, I did not write it here. State 1 to state 2. Then do the multiplication of P2, V2 into that. What do you get? Tell me if I'm wrong. P2, V2, N. Then I have the limits here. V2 minus N plus 1 minus, I can convert P2, V2 to the power of N as P1, V1. The whole denominator is divided by minus n plus 1. What did I get? What did I get? V to the power of n is gone, V to the power of n is gone. I got P2 V2 minus P1 V1 divided by 1 minus n. Can you write it? It's a simple derivation. You got P2 V2 minus P1 V1 divided by minus n plus 1, or you write 1 minus n, whatever you want. Shall we do one more derivation? I'll leave this to you. Come on, you got to work on this. I'll give you a relationship between P and V. Write it. PdV. Do PdV. So here the pressure is directly proportional to volume. It's not inversely proportional, it's directly. So like a linear relationship, like as though there is a spring. It follows the Hookean's law. Follows Hookean's law. Stress is proportional to strain. Load is proportional to displacement. Pressure is proportional to volume. This is a Hookean law. Like as though there is a linear element there, like a Hooke's element is there, like an elastic element is there. Derive it and tell me what is PdV. So again plug the same thing into P, do your integration, do some manipulation. Again don't forget state 1 to state 2, don't forget that part. Just tell me what do you get after a little manipulation. No, you just read out, I'll understand. P1 plus P2 multiplied by, any division is there? That's correct. You're right. P1 plus P2 divided by 2 multiplied by V2 minus V1. That's your work. You just need to do a little bit of manipulation. So I'm already repeating myself. This is a case where P is directly proportional to V, where there is a Hookean element, there is an elastic element, like a spring. If the question doesn't clearly tell you the relationship between P and V, put your hands up in the exam and ask what should I assume as a relationship between P and V. Got it? Don't assume whatever you feel like assuming in calculate work. You'll get it wrong. So you can have ideal gas law, you can have P inversely proportional to V, you can have P directly proportional to V, you can have P constant, any other variations that will be there in the problem? Okay, I'll read out again. P inversely proportional to V, P constant, P directly proportional to V. Anything else? Anything else? That's it. These are the three things. Don't overthink this. Yeah? These are the only three things. It's for you to identify in the question which one it is. Now that's what we will do. How to identify which one it is. Ready? Are we clear? Now it's just like a game show. You have to learn to identify. I'll give you some hypothetical scenarios. You identify and tell me, so that I know that you understand which PDV it is. Yes? Shall we start? All done? Shall we start? Okay. So because they always ask you about these piston, so I will be on the piston sort of examples, but you can take it to other examples also. Okay, my first example, some gas is sitting here. There's a piston and it's got some load. So you can convert that load to pressure. I hope you know how to convert the load to pressure. What will you ask for? Yeah, you will ask for area. I would have already given the load in terms of newtons. Why you will ask for mass? I've already taken gravity into account. Yeah? I'll give you the load in terms of Newton. If I don't give you the load in terms of Newton and give it to you in terms of kgs, then you know what to do. Got it? Okay. Then how do you convert it to pressure? You should ask for area. Okay, you'll get the area. Area will be given. Now, how does this gas even do work here? Because if it's simply sitting, is there any work? Is there any work? Then in the PV diagram, write that diagram. On the PV diagram, write the diagram. On the diagram, write the diagram of the initial state. What will you write on the PV diagram? Will you draw a line? Will you draw, will you draw a dot? Will you draw a line? Or will you draw an area? Thank you. You get it? Very good. You'll make progress. You will draw a dot. So what does it mean? That it has had some pressure and at some initial volume. So let me draw with you P, V. Shall I put a dot here? Okay. How do I make this go down? Should I change the volume? One second, should I change the volume? No. Excellent. How do I make the pressure go down? Excellent. Can you write it? Fantastic. Cool it. Cool. If you remove temperature, pressure. That's why I wrote the first thing, right? And there is a build-up. So which part of this is? Is it the blocking, or is it the open, or is it the release? It's a release. The third one. Got it? It's a release. You decrease the temperature, what will happen? The pressure will go down. But you should also do one more design work here. You should make sure that the piston does not move. Excellent. So put a pin and fix it. Put a pin and fix it. Fantastic. This is the third part. This is the release part. I'm talking about the release part. I'm just going whatever is coming to my mind, a sequence, yeah? But you should know which part it falls to. Is it blocking? Is it open? Or is it release? This is a release, yes? What are you releasing here? Heat. You're releasing heat and you're decreasing temperature. And in sequence, what will decrease? Pressure. What is the inverse of this? Keep the pin, make it go up now. What do? Heat it. Supply heat and get a heat build-up. This is the first one. There is a build-up. Why is there a build-up? You have put a pin. You have blocked it. You're not allowing anything to move. The volume is stuck. You have put a pin. Temperature increases. What happens to the pressure? Increases. Good. Ready for the next one? How do we do this? No. First you sequentially tell. First, is the volume changing? So should I keep the pin on or should I remove the pin? Okay. Then how to make it? Is it expanding or is it contracting? How do I make it happen? Or do some work. Some chemical reaction should happen inside the gas. Like it should blast off. Some explosion should happen, or you should supply heat from outside. What will happen? The piston will move. And why is the pressure constant? Because it is only pushing against the piston. So is it sort of like an open system? Yes. I know there is a piston, but it's sort of like an open system. Instead of atmospheric pressure, there is atmospheric pressure plus piston. That is your load that it's pushing against. Yes? So then you reach this point. How do I make this happen? At that point? So did the volume increase at that point? No. So at some point you have to again put the pin. Should you stop heating or should you continue to heat? Pressure will build up. Ready for the next one? How do you make this happen? Did the volume increase? Yes. Slowly, one at a time. Yeah? Keeping temperature constant, removing weights is excellent. If I remove weights, I know that the fact that the pressure will go down. But it may not expand. It may not expand because the volume is also changing. You are very, very correct. If I remove the loads, I know that my burden will decrease. My pressure will go down. You are absolutely right about that. But I still need to expand. How do you make it happen? You have to heat and simultaneously remove the loads. Very good. So I hope you know that the area under the curve is all changing. Yes? All the PDVs are different here. You might reach the same volume, but the PDVs are different. Pay attention to that in your diagram that you're writing. You may reach the same volume, your PDVs will start changing, like the diagram that I wrote last class. Some straight line, some concave line, some convex line that I wrote. Okay, very good. So you got it. Reduce the weight, keep heating. But it sort of looks like a linear line. Yeah. How to make this happen? I just change the shape, that's all. So did the volume increase? Yes. So is it similar to the previous one? The volume increased. Did the pressure decrease? Yes. But why the curvature changed? That's it. You're changing the rate at which you're removing the load. So now can you go back to the previous class and think of what rate I was talking about there? The rate of compression. So when you're compressing something, either you can change the rate by changing the amount, the deformation, amount of the deformation, or you can change the amount of loads that you apply. You can do a load control or you can do a displacement control. I think what I spoke about in the last class was displacement control. What you're talking about here is load control. But there too you can do load control and compress it. You can apply loads at whatever rate you want. You can start dropping brakes on it. Piece of cake, right? Can you go wrong on this now? You should not. I'll tell you the only reason why we go wrong on this. My personal experience. Just have to get overwhelmed and make everything murky in the head, and it becomes a cloud. It becomes nebulous. Game over. So the best way to overcome that is go take a walk, clear your head and come back. That's it. Don't put too much into the head when you work on these things. Is the volume increasing? Yes. So you can write in the answer, volume increased, pressure decreased. So what could have happened here? I have had to make it expand, but there is no pressure. How did I expand? I still kept supplying heat. Common sense, just don't forget P and V and T. At different times you end up a little bit forgetting. So again, request in the tutorial, please ask the tutors and tell them that we would like to write the diagram first and become confident with these diagrams, and then we'll take it from there. Clear? I think they know about it now. I think they also want to go with the diagram. Clear? Write the diagram. Because all these now will go into your phase diagram. Got it? So nothing to get overwhelmed. This can be part of your phase diagram. Yes? So they don't start blinking and thinking, oh, what happened here? This looks something. It's part of the phase diagram only. Depending on where you are. You're inside the two phase, or you're outside, or you're on this side. Get it now. That's why I learned to write the diagram. First you write these diagrams without the saturation points, without the phase diagram. Once you get comfortable, then start putting the phase diagram. Okay. Okay, let's do a little more exercise. Having fun? Let's make it a little more fun. Okay, now I am going to put the phase diagram a little bit here, okay? So don't get stressed out. That's why I already gave you an introduction here with the phase diagram. I think you're clear about the phase diagram. There's nothing to get stressed out. Since we are doing work, I will write all of these in PV diagrams. Yeah? Where am I? I'm in a single phase or two phase? Okay, excellent. What might have happened? Now firstly, did the volume change? Can you write it instead of guessing me here? Volume change. Did the state of the material change? Okay. Two state became what? One state. One state. What is the relationship between P and V? Is it inversely proportional? Is P constant? Or is it directly proportional? So you know what is there in your piston. What is there? There is a Hookean element. A spring is there. Got it? You just wrote it, right? P equals C1 plus C2 proportional to V. Got it? Did you not just write it? Linear element. Yes? So now you can yourself frame the question. Frame the question. There is some material initially at some pressure and volume in a two-phase with a certain quality of vapor. Did I correctly state out the first statement? Yes? Now you tell me, help me with the second statement. And it is in a cylinder with what over it? A spring-loaded piston over it. Okay, next sentence of the question. Next sentence of the question. Frame the question. How are you going to make that move? By heating. Excellent. So frame the question then. Frame the question. You already said it's heating. So frame the question. Use some words. Now that material is going to get heated from the initial temperature of T1 to some other temperature of T2. Why are you repeating with me? You frame the question. Then what should be the unknown of the question? What am I at T2? And what could be my P2? And what could be the work done? Anything else you want to pile on in the question? What am I at T2? What is the pressure at T2? What is the total amount of work that has been done to accomplish this? Anything else should be added to the question? Huh?
What is the contraction?
That I'll give you the relationship between P and V. The modulus. What you're basically asking is what's the modulus of the spring? I hope. Pardon? Yeah, so I will give you a relationship. I already gave you, right, previously. I'll give you something like this. P equals C1 plus C2. It's directly proportional. Got it? Yes? It's directly proportional. So what could be my unknown questions that I'll ask? What am I at T2? What is the pressure at T2? How much work has been accomplished to get to that T2? Anything else that I have to add on? That's it. Yes? So you can actually go from diagram to the question, which means what am I talking about? You should go from the question to the diagram before you do the numerical thing. Clear? Yes? You can frame your own question if you write the diagram properly. I'm going to write another diagram. Ready? One. So firstly, where am I? Single state or two state? Is the volume increasing or decreasing? Excuse Excuse me, read the diagram, man. Increasing or decreasing? Decreasing. Am I expanding or contracting? What is the relationship between P and V? Pressure is constant. Okay. First you tell me how that is achievable. So again, you have X material sitting in the cylinder and it has a piston over it with a certain load. So you know the area, so you know the pressure. How do you make 1 to 2 happen? Cool it. Sure? Sure? So there won't be any pressure change because there is no spring. Yes? It is like an open system. It just has that piston. So that piston will go down. How do you make 2 to 3 happen? Put a pin and then cool it further. Put a pin at 2 and cool it further. Then the P also will go down, T also will go down. I'm just going to re-emphasize again, I'm not writing PV diagrams because we are doing work. But you should learn to write PVs and TVs simultaneously. But you first get comfortable with PVs, then you can come to TVs. Either way, whichever. But I think since we are doing work and not heat, first I think you do PVs first. Once you get comfortable with PVs, then you can write TVs when it comes to heat. Very good. Put a pin at 2, cool it further. The pressure will go down. Excellent. So single state became 2 state. Tables, you ask the tutors how to read off the table. Okay. So what question can I ask at the end? Firstly, can I ask how much work has been done to come from 1 to 2? Can I? Can I ask how much work is done to go from 2 to 3? Okay. No, I can ask, and you can write whatever you want. You can write some 355 kilojoules. Get the joke? Put a pin and cool it. Is there a heat transfer when he puts a pin and cools? Is there a work transfer? No. Just checking. Will the internal energy change? Will the entropy change? Just the work is not done. Shall we do one more? Little complicated. Something that, shall I write one TV just for fun? No, I'll be on TV. Last one. Something I think I wrote in one of the earlier classes, but I wrote it on a TV diagram. This is one path. This is another path. What's the difference between one path, which goes directly from 2 state? No, in both cases work is done or no? Yes, obviously work is done. In which case it looks like more work is done. Oh really, you just guess the area under the curve. Okay. So then in which case there must be, because the volume, overall volume change remains the same, right? It looks like it's the same. Obviously it's the same. But you are saying already by looking at it that 1 to 2 seems like there is more work done. So will it face more resistance or less resistance? Obviously, that's why the work is more. So you know how 1 to happen. If the load keeps on changing when you are heating, how does this happen? The second part? How does the second pass happen? There is no increase in pressure. You just keep on heating, and then what happens? It will phase transition, yes, it will phase transition, then what will happen? Then what will happen? So I'll make it a little bit easy. If I write like this, what will happen? That is also possible, the dotted line I wrote. So you started at a 2-state. There's only one piston sitting on it with some load. So you know what is the pressure, you know the area. Then you heat it. What will happen? The state will transition, temperature will remain constant, and it will start to change its density, volume will change. It will push the piston, then it will become completely saturated vapor. Then what happens? I just wrote two ways. If I write the dotted line, what happens? What will happen? After it becomes completely saturated vapor, what will happen? Huh? No, you are constantly heating. So how does it go on the dotted line? No, I'm heating, right? Hey, remember, this is not TV, this is PV. So I'm heating, it becomes a complete vapor. And then if I continue to heat, does it go with the dotted line or does it go with that other line that I wrote? It goes with the dotted line. Got it? What are you doing? You're just expanding and heating, that's all. When does the pressure buildup starts to happen? As soon as I reach saturated vapor, I start applying load. Yes? Okay. That's why I just want you to pay attention. Oh, for fun, can I go like this? Start taking the load out, but continue to heat. You know what will happen. You'll come down. Dotted line. Got it? Load is like a block, a resistance. Clear? So 1 to 2, you know that I'm changing the load for it to go like that. If I don't change the load, is it ever possible for me to go like the first way? Really? There the load is changing with volume and it is phase transitioning and it's going directly out because the load is constantly changing. So that is possible only if I keep loading, or can I achieve that with a constant load but also make it like as though the load is changing? Is it possible? Can I keep a constant load and change pressure ever? If I only put a pin, the pressure will change. Got it. But if it's a moving piston with a constant load, can the pressure ever change when you are heating? Slightly difficult question. Don't overthink this. I'm just asking for fun. So you know how the first pass went. First pass went because your load kept increasing. So which means there was a resistance that kept on happening as you went along, which means there was a spring, or you externally kept applying load. In the second case, you went flat, constant load. But then once you reach a saturated vapor, many things can happen. It can keep going constant, or you can start applying load, or you can start removing load. So little homework, all this should translate into TV diagram. Because what will come hand in hand is not just the work done, but also how much heat has been transferred. So my only question to you now is, before we split, shall I get out of work and get into heat next class, or shall I stay in work? Shall we move on? Are we good? Okay, then I'm going to wind up work. we will move into heat. Catch you guys.